Okay, today's question is how does a 555 timer work and how can you make it work better? And the reason I say that is because it actually wasn't designed very well. Let's take a look at inside 555. There's basically 3 resistors. They're all equal, so 1/3 of the voltage is here, 2/3 is here, and they've connected these to comparators. It's hard to stand in front of this thing. And they have a latch. They have an output. And they have a gate. Or a port, or whatever you want to call it, called discharge. That's basically what's inside. There's some other inputs, but we're not going to worry about them. Now they call this one the trigger. When it's low, it's going to set. Set means the output. It's going to go high. This is the output. That's an S. Now, when this one goes above 2/3 of the voltage, so we'll put low on this side, it resets the output to low, so you can get high and low. What you do to get this guy to work, you connect those to a timing capacitor. So when you turn the power on, there's no voltage here. So that gets set and we get a high output. That's going to charge up the capacitor if we, of course, connect that to a resistor to some positive source. When it gets to 2/3 of the voltage, we get a reset and that goes low. Now that transistor is actually, there's an inversion in here. So that gets turned on and discharges our capacitor. If we put a resistor in here, right? So we power it up, there's no voltage here. This guy gets set, we get an output. That's low if that's high, so that's open circuit. Positive is going to charge up the capacitor. We get 2/3, we reset. This gets turned on, discharges our capacitor, but we have a bit of a problem. We can't just put that on positive because they're going to fight each other. Now what people have been doing is they've been putting a resistor positive in here instead of that one. Okay, which of course wouldn't work. So now we have charge current and discharge current this way through ground, and that blocks it from being charged. The problem is, if we look at the output, we're going to have the capacitor charge up through 2 resistors and then discharge through 1 resistor. That's going to give you a very unequal output. You cannot get a square wave out of this circuit. But there's a way to fix it. The original engineer should have done. But they didn't. What you need to do, of course, get rid of that stupidity. And what you need is a new way to charge that capacitor. You need a gate. Well, we can make a gate. We can make a gate over here. put a resistor. Alright. Oh, too used to making grounds. That's going to be, when that's high, we turn on the transistor. And there we go. Charge gate. So when that's high, turn that on, charge the capacitor. Capacitor gets to 2/3, reset, turns that off, turns this on, discharge the capacitor. Now you notice that resistor and this resistor could be replaced with a pot. Right? Very easy to do. Just get rid of that. Get rid of that. And we now have charge, discharge, capacitor. And we can get any duty cycle we want. We might want to put a couple of resistors in there. Doesn't matter. That's going to be much better circuit. All you need is a NPN, and I've used 56K or whatever, doesn't matter. Anyway, let's go to the breadboard and scope and see it if it works. So as you can see, with the addition of a transistor charge gate, and you stick a pot in there and you can get any duty cycle you want. Assuming it syncs. No problem. They should have put that in the chip, but they didn't.